Good afternoon, everyone. Welcome and thanks for being here. My name is Noeli Reyes. I am part of the team of Caribbean Climate and I am going to be the moderator for the talk today, which is the first tech talk of this year that is focused on the web soil survey. Before we start officially, just give me a moment, please. There is some information that is important and we want to share with you. This event is going to be in Spanish. If you want to listen to the content in English, you just have to select the More three buttons that appear in your screen, be it your mobile or your computer, and you can select the English interpretation channel, and we are going to be translating, interpreting live all of the content. If you require interpretation for American Sign Language, you can also activate it by selecting ASL in the submenu. We also have habilitated the question and answer menu for Zoom. At any point during today's talk, you can write your questions, and at the end, we'll have some time to clarify any information that you wish to. The resources for today, well, I am going to be here along with Laura Marin, who is going to be assisting me. We are from the Climate Center of the Caribbean, and we also have the director for the center, Dr. William Gould. He is going to be introducing himself more formally in a few minutes. And of course, we have our presenters, Manuel Matos and Jacqueline Vega, who are also soil scientists from State Soil of the Caribbean. We are going to have an introduction from the Climate Center of the Caribbean and some of the tools that we use. And then we're going to go into the presentation and the demonstration from the web soil survey that is going to be presented by Manuel Matos and Jacqueline Vega. And then we're going to have questions and a summary and evaluation at the end. The Climate Center of the Caribbean is one of 11 centers that provide information, tools, and collaboration efforts and resources. We provide this to farmers, educators, soil managers, and other scientists. In our case, we analyze and provide scientific synthesis. We develop tools and transference of technology, and we also communicate scientific and educational material. We have a lot of tools that have been developed throughout our time and the hub work. But today, I just want to talk about some that are very important for decision making. This is a way of supporting you in your decision making. The first one is going to be the guide for climate adaptation. And we're looking with this guide to help farmers and soil managers to develop plans to adapt to climate change and changing climate. And this guide focuses on guiding you through 5 steps: define, analyze, evaluate, identify, and monitor the areas where you have your projects. We also developed specific projects for different types of farming in this project of climate adaptation. We have, for example, coffee and different types of foods, and you can get this through our webpage. We also want to focus that our tool of farming planning, it's one of the tools that people ask for and use the most. The user with this tool can select an area of their interest to create a report of environmental characteristics that are part of that polygon. that we are seeing. We have 19 levels of information that allow users to be able to develop the soil and understand other characteristics of the geospatial spatial information. We also have agricultural statistics tool. This tool is available only for Puerto Rico and not for the Virgin Islands of the United States. Other tools are available for that, but this allows users to go in and find a crop of their interest and see the distribution in a region, municipality, or neighborhood in Puerto Rico. Data can be downloaded in KML and of course in table form if you want to use it in a different type of project or present it in a different way. Similar to our farm planning tool, we also have a data viewer, and basically this tool allows the user to activate their location wherever they are without needing to draw a polygon or find an area, and it allows the user to know everything that is happening in that space in terms of geospatial data, such as elevation, uh, water, type of soil, uh, the different temperatures, precipitation, monthly, in average, among others. And we also have other uh, citizen science tools that allows users to make decisions. It's called Seymour. And basically, if you want, you can create a report. You can take pictures of drought or not in the area. You can upload it into the platform for your benefit and also for the benefit of other farmers that are looking for information related to the drought season. And lastly, we want to emphasize that we have a board game, Caribbean Climate Resiliency Game, and this has been developed with Windrock International. It allows and serves as a tool so that players can understand how their decisions in the farming area can help them with their climate resiliency and what goes on with the health of your soil throughout time. We are in the last phases of the development of this game, and we hope that this becomes a tool that is important for all of you. Without further ado, I know that this was brief about our tools, but I am going to leave you with Mr. or Dr. William Gould so that they can talk to you about what we're going to have in our tech talk today. Thank you to all our participants today. I hope that we have a meeting that is useful for everyone. We want to share practical information that you can use in your work and your life. I want to thank presenters Manuel Matos and Jackie Vega. It is a pleasure and honor having you with us, presenting all of these tools that are so important from the NRCS. Manuel and Jackie, both of them, have their education from the UPR in Mayagüez, and Manuel has worked in 5, 6, 7 states of the United States, and he has gained a lot of experience in different types of climate, soil. Of course, Jackie has also worked in different states of the United States, but we are lucky to have them here in Puerto Rico to share all of that experience and talent locally and to help us with the needs that we have here specifically. I have worked for many, many years with Manuel, and always, always, he has been ready to share information about NRCS, his knowledge, and he will participate in virtual meetings and in-person meetings. They have shown his experience and knowledge and his willingness to share this with the public. We are working also with Jackie, the same as Manuel. There's a lot of enthusiasm in sharing this information and what is being developed at the NRCS. So it's a pleasure to have them with us. So I'm going to leave you now with Manuel so that we can start with the presentation. Thank you so much, Dr. Gould, Climate Hub, Noeli, Laura, everyone that is involved in the creation of this series, Jackie, for allowing Jackie and I to be able to present to you information on the main tool that we're using to publish the most important data that we have about the soil and the surveys. So you can let me know if you're seeing the screen with my presentation. It's up already, ready to go. Perfect. So we want to talk to you about the tool, which is called Web Soil Service. And for that, we are going to tell you a little bit of a history of what this is involved here and what is the impact in the Caribbean, how we develop them, what are the components, and mainly show you how to use this tool to generate reports on soil and interpretations so that you can obtain information from the survey so that you can use it to manage your properties or soils. Okay, here we go. A little bit of the history of soil surveys. Soil surveys have guided the land use in the US and territories throughout time, and this started in 1899. This year, it's going to be the 126th anniversary of the collection of data from the soil survey. This is an effort from the USDA and where we provide funds so that we collect information on soil and we make it available to users free of charge. This was created to support agriculture, development, and conservation. From the very start of the Department of Agriculture of the United States was involved, and then of course the NRCS started this in 1935 to work on this with the conservation of soil and land. And in 95, it changed to the name of Natural Resources Conservation Service, which is NRCS. And this is all under National Cooperative Soil Survey, NCSS, that the agency and the NRCS agency leads this effort, but is also supported by academia from the different federal agencies and the public that allow us to get the information, and they also suggest where we can move to so that we can improve our soil surveys. And this is happening since 1899. Right now, from 2005 on, more or less, we would provide this as a manuscript or copies that would be distributed. But then in 2005, we started to 2005, we started to use the Web Soil Survey platform, which is digital. And one, we have to define what soil survey is. It contents maps and describes soils in a defined area. It includes soil types, locations, classification, limitations, also interpretations or models that allow us to identify what are the best uses for that area. And as I mentioned before, this is used to support decisions in farming, construction, conservation, research, and education. But it goes further than that because it can be used in multiple things. A little bit of the story or the history, talking about Puerto Rico and Islas Verdes when we talk about this, but it was also done in Cuba, and we have also worked in Haiti. But in the case in Puerto Rico and the US Virgin Islands, the collection of data started in 1899 when it started in the continental US, and we started with the first publication of a hard copy and manuscript. This was in 1902. 1903, we published the first soil survey of Puerto Rico, which was apart from Arecibo to Ponce. We started to collect data in the 1920s in Puerto Rico, but also we also worked with St. Croix, where a group of scientists started collecting data and publishing these surveys. In 1932, for example, we had the soil survey for St. Croix. Then we had in 1942 the soil survey for Puerto Rico, which was published, as I said, in 1942, which is called the Roberts Soil Service, which is a compendium of all of the island. Then in 1965, we published from the Lajas Valley, the soil survey, and it's the most detailed historically that was developed in Puerto Rico. It was under Order 1, which had the minimum delineation, sometimes an acre or less than that. Then we started collecting information on the US Virgin Islands, St. John, St. Thomas, and in the 70s also, we started, I don't know if you remember, what was called the Green Revolution, where we recognized the need to understand the different types of soil so that we could improve agricultural production because the population was growing. So we started collecting rapidly information, and we gave it some funds so that we could have the soil survey of the United States and Puerto Rico, and the US Virgin Islands was not a sole, was also included, where we had Mayagüez, Humacao, San Juan, Ponce, and Arecibo. Then we started researching in the area of Luquillo and El Yunque, and we started also working in Campamento Santiago and Fort Allen. Then we updated the information on El Yunque and Luquillo, and we worked on the soil service of San Germán, which was the last manuscript. And then in 2012, we also updated the soil survey of El Yunque. And from then on, we continue to update through the Web Soil Surveys platform, which is published every year on the 1st of October of each year. And how do we work on this survey? We defined the soil survey area. We gather background on preliminary data with all of the geographic systems to create all of the levels, be it geographic or geologic information, climate information, anything that can offer information that influences this so that we can start creating the models for the formation of soil, and we can accelerate the data gathering and the creation of these products. We have field investigations of the representative areas. We have lab testing. With that, we create soil classification areas. We have the delineation of the map units, and we create with that, not only do we publish information on what is going on in the area, but we also have interpretation and mapping. These are models that allow us to predict how the soil is going to behave, depending on the management that we provide. And then we publish the soil survey. Here we have a little bit of a briefing of how we define the soil survey, starting on the left up. We have here the soil survey for San Germán. Then we gather the background data and we create preliminary maps. And then we go to the field investigation, and we have the description of the soils that are very detailed. And from those descriptions, we start identifying representative areas or to continue the process where we have lab testing in our labs, our national labs that are located in Nebraska, which is the place where we have the National Center for Soil Survey, and where the labs are located. And that's how we start to classify soil. And why do we do that? That's a way in which scientists can communicate throughout the world with a system of soil classification that is ordered and structured. We have the soil classification of the US, which is called soil taxonomy, and it has the keys to soil taxonomy. With this information, we start mapping the different units. And I'm going to talk about what map units are in a few minutes. And then we designate the segments in the area, and we identify what the differences, significant differences are, so that we can divide the area. We have different models for interpretation and mapping, and then we publish the soil survey through the platform, which is Web Soil Survey. I would like to discuss a little of our time to talk about map units, because this is what you're going to be seeing as you use the tool. And basically it's a delineation of this area in the landscape where we find soil that share different characteristics. Each map unit has unique symbol and name, and the main component, the texture, and the landscape. And this is included with some symbols, which are the map units. That helps us to separate the different soils in the landscape and to understand the properties and behavior of soils under different conditions. And that's where we apply these interpretations. And as we move with the information, these map units, it's important that we know that this is not pure. It's not a type of soil that is unique or pure. It's going to have components that are that are dominating in the landscape, and the soil around is going to have similar properties. So we want to group the soils that behave similarly, because if we have maps that are too detailed, that would lead to confusion of the user. So we tried to separate these segments in the landscape that are going to behave similarly. We describe the different issues or characteristics of these units in the landscape. And we're showing you here 4 kinds of map units. In Puerto Rico and Virgin Islands, we have confiscations, which is a unit that has just one name in the map unit title. And then we have the others that are the complexes, that are soils that occur in a landscape that can be replicated. And then we have the associations and in undifferentiating groups. These are not very common in the Caribbean area. All of this can be summarized and published in Web Soil Service platform. As I mentioned, this was launched by NRCS in 2005. To access this tool, you need an internet connection, you need a computer, or maybe a field tool. This includes maps with soil reports and the suitability ratings. And it's used for farming, for permits, for planning and research. As you can see to the right, that is the main page for the Web Soil Survey, which is the tool we're talking about. And at the bottom, we include a QR code. So if you want to copy or download the link, here it is. In this part of this workshop or seminar, we want to give you a description or a live demo of how this application can be used. So I'm going to leave you now with Jacqueline Vega so that she will continue with the presentation right now. So Jacqueline, the screen is yours. Can you hear me? Yes, we can hear you. Something that I want to emphasize that Manuel had mentioned is that this year, it's going to be the 20th anniversary of the launching of this tool, which was created by NRCS and was developed by the National Cooperative Soil Survey. Right now, 95% of the data in the United States, including Puerto Rico and US Virgin Islands, it's online. The 5% that is missing, we're hoping to complete briefly. And we want to use this new digital platform to be used instead of those books and manuals. And of course, we know that this is good for engineers, researchers, farmers, and other related professions. Something else about this tool is that if you want to have a more detailed planification, you need to visit and an on-site investigation so that we can get data of the area of interest that is more is live almost. So I'm going to mention a little bit about what's on the page of the Web Soil Survey, and the next workshop we're going to be talking a little bit more in depth. So I'm going to give you a brief summary of this tool. Right here in the center, you're going to see the green button, which is Start WSS. which is a web soil service. This is the simplest way of beginning the area in this area. But at the left, I want to show that there are several links that have information related to soils that are important. So I'm going to mention just some of them. For example, we have the archived soil surveys, which is where we scan all of the surveys historically and are available to be downloaded. The other link that is very much used is the official soil series description, which is a link where you can find information that is more detailed on some of the, or a particular series. At the right, you can see I want to. The first link says Start Web Soil Survey. This is another way besides the green button where you can start using this type of tool. And the other thing that I find very important is find information by topic. You can see down in this list, and this table shows all of the interpretations in alphabetical order that we have, and it tells you exactly where you're going to find these interpretations. For example, the ASTO group index or classification, you're going to see a tab in the Data Explorer, and you're going to see properties and qualities. And in soil property and qualities, you're going to find it, qualities and features. It's just so that you have an idea. At the bottom of the beginning page, you're going to see the announcements and events where we update or offer information on any update of what is included in this tool. And if you want any information, you can register also in that sign up for email updates via Gov Delivery. So we're going to start. We clicked on the green button. We're going to start a new session. Jacqueline, I don't know if you're going to continue with the slides or you're going to be going to the link directly. You need to share your screen. Are you seeing the screen? Yes, we are seeing the screen. Manuel, verify, but at least we can see Jackie's screen. There we go. Manuel, stop sharing. Here we go. We're all set. Let's continue. Yes. Once you select an area or the web soil survey, it's going to take you to the main screen. We have an interactive map, and we see the map of the United States. If you want to extend or be more specific on the area that you want to evaluate, let's change it now to Puerto Rico. It then changes the screen and moves us to Puerto Rico. And I'm going to mention a few things here. In the upper part, we see the main menu. And this menu starts with Contact Us, and it leads us all the way to Help. Let's see if any of these links, like Archives Soil Service that were and the main page, are also here. We also have the glossary where you can find definitions or terms that you might not know, and you want to have some more detailed information, you can use that. We have preferences. It's important here to revise this before you generate the report. We have to make sure that the application preferences are selected so that when you have a report, you're going to see a different page where you're going to have the information reflected. We have the link, and I'm going to talk a little bit more about this later on. It's a QRL link on the web, and we can copy this link that is going to be generated, and we can share it to other people so that they are able to see the same area that we are seeing and we are working on. In logout, we always call to close the logout. Don't use the X, go to the logout and log out properly. And of course, in the help, we have information on how we can work on those reports that we're creating. So we're going to start with the first step for generating a report. And the first one is to create the area of interest, define that area of interest. And there are several ways in which we can do that. The first one is right here in the interactive map. You can see, you can have zoom in and out so that you can come closer or get farther away from the area that you're seeking. And you're going to have these two options that we're signaling here. Define the area in using a rectangle, or define the area using a polygon. You have more of a freedom of creating the shape of the area that you're interested in. The only limitation in these two options is that it has to be an area that is less than 100,000 acres. If you try to gather more of a space, it's not going to allow you to do it. The other way of defining the area is here at the left. It's a method of importing the area of interest. So you have these different options. You can establish what the boundary is, or if you have the zipped shapefile, is going to project the area of interest. The same limitations that we encounter by using the polygon is what we have in the import of area of interest. It has to be less than 100,000 acres or else it won't project. The third way of defining the area of interest is this one that I have here, quick navigation, and you can here enter the address of the area that is of interest to you and that you're going to be working on. You can share the state and the county, which in the case of Puerto Rico would be more of the municipality, and you can hit view and it's going to showcase that area. You can also enter soil survey area, and you can include that information if you have it. And you can choose the area where you're working on. And latitude and longitude. If you have that information, you can enter. You hit view, and you are going to see that it takes you directly to that area of interest. For the quick navigation, if you're going to use the soil survey area, there are options for more than 100,000 acres. In this case, for demonstration, I am going to use a rectangle to define the area that I want to research. Here we go. Now we can see the rectangle in the area. Once you select that area of interest, you're going to see that the area is going to be marked by lines that are diagonal and blue in color. And then I know that this is the area where I'm going to be working, that marks that area. In the tag that you see to your left, there's a legend. And these are all of the options that I can choose for my report. If I want to change the background, Instead of having an aerial photography, I want the topography. I can also do it and choose that as my background. Usually we use the aerial photography. Another option that you have is that you can edit the transparency of that aerial photography. If you have that layer, you can have transparency as you decide in the percentage that you decide to use. Once that we have the area identified, we know where we're going to be working, we're going to go to the second tab, which is the soil map. And in this tab, we're going to observe that we have the rectangle where our area of interest. You're going to see to the left the map unit legend, where you're going to find the different map units that are in that area of interest. It's going to have a symbol, a name, the acreage, and the percent of the area of interest that is represented. If I want to find more information of one map unit, I have to just click on the name and I can read and find more information. We can observe here that when I created my boundaries, there was a warning at the bottom. Of you can see what it's telling me is that this map was created on a scale of 1 to 20,000. And when we get too near, would create opportunities of misinterpretation on the limits of the soil, because maybe there are variations that no longer exist. And it's giving you a warning of something that you might want to take into consideration as you do your interpretation. In this case, if I wanted to just receive or get a printed version, I can hit printable version, which is to the top, to the right. I can give it a subtitle if we want. I am not going to do it right now. I'm going to hit view. And supposedly it's going to open a different page with this map of the area of interest. We have the map legend. We have the table for the map unit legend, also with the symbol, name, acreage, and percentage of the area of interest. If I want to create even more, or I can click on add to the shopping cart. We can give it a name if we want to. And I start moving for the self-data explorer option. This tab has several subsections or sections. It has an introduction to soils, and it gives you general information on the soil that is part of your area of interest. It tells you the suitability and the limitations, if the soil and the land is adequate for farming, construction of housing, or other uses. And then we have the third, which is the properties and quality and the characteristics, physical, chemical, of the soil. Drainage, what type of material you find there. We also have a new section, which is the soil health properties. It's a new section. I think it's been available for a year. We also have ecological sites tab related to the characteristics that are specific for this. And when we're dealing with conservation and restoration, this is very valuable. And then we're going to have the ecological sites by map unit. But when we look at the report, we're not going to have the whole description because there are some areas that are still being worked on and will be available in a web survey later on. And then when we have the soil report, which is the last tab, is going to allow us to have a personalized report or information of a particular area. We have an inventory of the area of interest, and we have several reports here. The description of the map unit, description of the unit map, but brief and generated. Those are the only two that we have. Let's assume that I have my area of interest, that I'm going to generate several maps. So I'm going to go to land classification, and I'm going to choose, let's say if I have to work on a determination, and part of it is to know if I have hydric soil or no. So I'm going to come to the hydric rating by map unit. This is available in that menu. I'm going to click on view rating, and it's going to give me the map with colors. I'm going to use the legend to figure out what it represents. And we see the different colors with the percentage of hydric soil. For example, if we have a very intense green, means that there is no hydric soil. The one that is a little bit more clear or transparent gives us 1% to 2%. If I want to see other reports, I go to add to shopping cart. I'm not going to give it a name for this example. I'm going to start looking at other reports that I would like to develop to determine my project. I'm going to go to soil qualities and features, and then water features. I'm going to generate a map of flooding, which is called flooding frequency class. I'm going to see a color map, and then I have to look at the legend to see the results. And since I am interested in this map, I'm going to also add it to the shopping cart, where we're going to do the same thing with the pending and the ratings. And I'm going to keep adding to the shopping cart. And I'm going to continue doing this with all of the reports that I want to generate. But we have a maximum number of reports that I can do. I can generate, and I have up to 10 options. Once I am done with all of the reports that I would like, and I am interested in obtaining this data of my area of interest so that I can continue to work. So I would like to have the data. So I go to the tab that says download data, and this is going to create the information that I'm looking for. And to have this created, I have to choose the download soil data, and I have to hit on creating so that it generates a link. Once that is generated, I can record it anywhere that I want, and it's going to bring forth all of that information that I gather from my area of interest. If I like to download a soil survey, I can choose soil survey area. I'm going to go to the state that I'm going to be working. In this case, I'm going to choose Puerto Rico, and I choose the soil survey area that I'm interested in. Right here, let's say that it's a Mayagüez area. I'm going to download that link, and I'm going to record the information where I wish. And I can use it also through Google Earth. I'm going to go back a little bit because I forgot something. And it's the option of link, which is in the upper menu. That is updated with the information of my area of interest, and I can copy this link information and send it to somebody else, and that person is going to be seeing exactly what work I did in that area. Let's say that I generated my maps, I downloaded the information, tabular and physical, and I already have everything I need. I'm going to go to the shopping cart, which is also saying free. And I'm looking at the table of contents, and I want to know if everything that is in there is something that I want. So I want to mark whatever it is that I want. Sometimes we don't choose glossary because that would take a lot of space. And then I'm going to check out with the information I chose. And I have two ways of obtaining a report. I can have it now, or I can download it. We always recommend to have it right now and then download it later. That's going to take a little bit more time. It's not more than, it's not all that much, but yes, it's slower. And now I have the whole report, and I chose to see now, and it's supposed to generate. Here we go. Now we have the report generated. Can you see? Can you see the report? Yes, I can see the report. We are seeing Custom Soil Resource Report for San Germán area, southwestern Puerto Rico. That is the final report. Once you have the area and you selected all of the routes that you want to use to be able to evaluate that area of interest, you're going to do your checkout. And this is the way that you're going to be receiving the final report. It's going to give you the area where you're working, information of the agency. It's going to give you an image of the area of interest, and it's going to include the contents table, an explanation on how soil surveys are conducted, information on the soil map, the first map, the map unit information. We're going to have the map legend, the map information, the map unit legend, as well as the map unit descriptions in the area of interest with the names, numbers, etc., acreage and percentage. What is contained in the descriptions. And here we're going to have information more detailed, talking to you about the composition, the description, elevation, precipitation, and the different characteristics of that area of interest. If we go down, continue to go down, we're going to see that now we're going to see the rest of the reports that we selected. Legend, table, description. We have the one for flooding, as well as the legend and other information related. And the last part are going to be the reference sources. I think we did it a little bit fast and it was brief. I want to add. Can you see the PowerPoint? No, not yet. You see it now? Yes, I can see it now. Instead of seeing the slide, here we go for the presenter view. There we are. For those people that are doing field work and you want the applications for Androids or iPhones, we have that Soil Web application available. And you see there at the right, the links that will give you access to these. You're going to see, or you see here in this presentation, the screenshots. You select the area, it's going to give you all of the information that is included in that particular area. And another source that we have was created by California. It's a California Soil Resource Lab. There are interactive maps. And I'm showing you just some of the maps. Not all of them, or not all of these apps include Puerto Rico. And that would be all. I think I spent all of my time. If you have any problems, you can find an email, soils hotline at USDA.gov, where you can find information. And also we see here information for our QR code and where you can follow us. And this is going to be great for any people that want to show or use this information on your own. We are past our time, but we want to thank all of you for being with us, and anyone that wants to stay to clarify or have any questions, please stay with us. But we do understand that if you have other commitments and previous appointments, we understand if you have to leave us. So I see some questions. Manuel has some that I can read for other people's benefits, and then we're going to the rest. Let's start with two questions. What do you think, Manuel? Perfect. The first question says, thank you for your work with the classification of native vegetation in Puerto Rico. And they ask if the descriptions of the ecological spaces and the map units are completely similar to those that are offered for other jurisdictions, because it's very important to work with solutions based on nature and native plants of Puerto Rico. So they wanted more information related to those classifications. Yes. The answer is yes. We are following in the generation of the description of ecological areas. We're using the national standards as part of what is demanded of us. Otherwise, it cannot be published. The information cannot be published. It goes through a quality assurance process to be able to be published. And what is going to be contained there is the ecological description, and also, obviously, information on soil, climate, vegetation, but also the most powerful thing that is going to be included is a model of the different states and the transitions. The transition models, whatever use or whatever has happened in that ecological space, so that the user can identify that state and use it as a starting point, to use it as a roadmap to follow, mainly with the conservation goal in mind. But the answer is yes. We are using the standards, national standards. And I saw another question that is related on when it's going to be ready. We are right now in the collection of data in the field. I can mention that the main collaborator is Dr. William Gould and his Forest Service team, who are helping us collect the information, and we're work on the collection of data in the field. It's going to take us at least a year, an extra year, to be able to have these concepts provisionally, and the states of transition published in Web Soil Service. Those are the expectations. Right now, you can see the names, but the descriptions are not available yet. But we hope, I understand that as we've done with the collection of data, it's going to take us a little bit more, 1 year. Thank you so much, Manuel. I have another question in the chat. Some have been already answered, but it's where is this available, the tool? They're calling or they're talking from the Dominican Republic. Unfortunately, we don't have it. This product is generated for the United States and the territories, states and territories in the Dominican Republic or in the Hispaniola in Haiti. We worked and published based and using the same standards and were available for a time. But no, this is about the Caribbean area, the islands of Puerto Rico and U.S. Virgin Islands, St. John, St. Thomas, and St. Croix. Unfortunately, this information is not available for the Dominican Republic. Thank you for that clarification. Up to now, I don't see any other question in the chat or the Q&A section. But please, if you try to use the tool and you have any questions, use the links that Jackie shared. You can write to us. As I mentioned at the beginning, this talk has been recorded and it's going to be available in our YouTube channel very soon. And when it's live in YouTube, we're going to be sharing an email notifying so that you can check out the content once more. So thank you for being with us. Thank you for Manuel, for Jackie, and the interpreters for their work and services. And thank you to all the participants for their time and attention. We hope you're fine and have an excellent afternoon. And thank you from our team at the Caribbean Climate Hub. Thank you.